Good afternoon and welcome back to the class. I hope my screen is visible. If somebody can just say yes or no.
Yes, ma'am, it is.
Okay, great, fantastic. So what we've done up till now is after finishing off with sales management, we are doing distribution management, and we started with the basic concepts of distribution. That is, why do we need distribution management? What are the discrepancies it takes care of? What are the channel flows it takes care of? How does it result in the final product, brand, or service being delivered to the customer at the right time, at the right place, and so on. Once we discussed the basics of distribution management, we understood it with a small example of a car and a soap as to how, even though the basics remain the same, how the implementation completely differs. And after that, we came to logistics management, because how does this actually happen? And when we started discussing logistics management, there are three things in logistics management: warehouse, inventory, and transportation. And the basic fundamental of logistics management is cost reduction, capital reduction, but service improvement, which means that the three don't work against each other. The three don't work in isolation, because there's nothing called I in the world of business. The three work together. Yes, we want to reduce the cost, we want to reduce the capital, but we also want to improve the service. And therefore, there's nothing called maximum and minimum, but optimum. And then we went ahead to discuss about warehousing, where we saw that how a warehouse is the place where assortment, allocation happens, all the supplies are brought together. And again, some basic fundamentals of proper warehousing, because what is the purpose of a warehouse? Movement, storage, and information transfer. And I'm so sorry. Movement, storage, and information transfer. And for that to happen, there were some simple basic rules like movement in a straight line. The things which are fast moving should be near the entry, first come, first out basis, and information transfer should be on a real-time basis. And therefore, what becomes extremely important are the technological advances, both in software as well as equipment, because unless and until there is complete transparency regarding information between all the stakeholders, we cannot have cost reduction, capital reduction, and yet at the same time, service improvement. So now that we have a warehouse, obviously we have an inventory over there. And when we are talking about inventory, again, why do we need inventory? We need inventory for batching economy. Now, what does it mean? So acquisition. So when I'm buying raw material, even when you do it, so when we go to a grocery store, sometimes we find that they say that if you're buying 1 kg, then it's for X price. But if you're buying 1.5 kg, then the price is slightly reduced. Economies of scale. Similarly for business, so during acquisition, I may buy more raw material because of a better price, but that results in inventory. Similarly, production, I would love to produce as and when the customer order comes, but that is not possible. Tata Motors can't sit and say, okay, when the customer will place the order, then we will manufacture the car. No, the production happens on a regular basis, and again, inventory. And then transportation. Sending a full truckload or half truckload is far more economical, and therefore, inventory. Obviously, we need inventory also because of safety stocks, which you saw in yesterday's example. And finally, seasonal demand. So I need winter clothes if I'm in North India, maybe only in November, December, January, February, but for the rest of the time, maybe they are creating an inventory. Inventory is a necessary part of business. Sometimes I use the word necessary evil. We can't live without inventory. We can't live with inventory. Because if it is too much, then we incur cost. If it is less, then we lose customers. And therefore, the biggest problem that we face in business is to have inventory, but which is just enough. It is not less, It is not more. Because when it is less, my customers go back empty-handed, which means service improvement is not happening. And if it is more, then the cost increases, the capital increases, which again means I'm not achieving the objective of logistics management. So we just need enough. And that is such a big issue. When I'm talking about inventory, the example that I gave you yesterday was about inventory visibility. What does it mean? Today, technology has advanced so much that sitting here, I can monitor how much goods, the quantity of goods, the movement of goods in my different warehouses with different channel members. And this is something which you and I witness every day. Sitting at home on that little app on the phone which keeps ringing all the time, we can see how much inventory different online e-stores, e-retail stores have in their warehouse. I mean, you and I as customers. So on a real-time basis, when we can see inventory visibility, that's where we are, and that's where it's happening because of, as I keep repeating a billion times, due to excellent technology advances that have happened, and which is an integral part of supply chain and logistics and distribution management. Obviously, when we are talking about inventory visibility, there are a lot of formulas, a lot of ways in which people decide how to categorize their inventory, which is very important. One of the most famous is ABC analysis, which is very simple. What is ABC analysis? Just forget about what is written on the right-hand side. ABC analysis says that for anything, you can categorize things into three categories, where A is most important, B is second, and C is last. Now, depending on the company, they may like to categorize their inventory on the basis of price. They may like to categorize the inventory on the basis of the demand. They may like to categorize their inventory on the basis of the perishability, whatever, right? But why do we categorize? We categorize so that we know that how much importance is to be given to which inventory. If I have categorized those inventory as A, which are fast moving, then that means I have to take care that they are stored. I have to place more importance on them. This just allows the company to put the right emphasis on products or categories which they think are important, because another hard reality is, though I would like to give equal emphasis on everything, it's just not possible. So this is just one of the ways. There are many ways of categorizing your inventory, and which companies do all the time. But the pertinent question, the important question which keeps everyone busy is how much inventory? And that's where our next thing comes, which is economic order quantity. Now, what is economic order quantity? Economic order quantity is that quantity which, when ordered, ensures that my cost is not increased, and at the same time my customers do not go back empty-handed. Now, if I'm translating it from a simple graph, we will do this. We will solve this. So any inventory, please understand, has two major costs. One is the ordering cost. So this is the ordering cost, and one is the carrying cost or the holding cost. So what does this mean? Again, go back to life, because business is nothing but life. I mean, and if we understand that, we can solve most of the problems. So when I order something, when you and I order something, so let's assume we have ordered vegetables, or you've ordered something to eat, whatever, rajma chawal, pizza, or some hi-fi, whatever, you've ordered something, right? Now, how do we order? Either I go to the vegetable vendor to order, which means I'm making an effort, I'm walking down to the store, and my effort is money. Or maybe I'm picking up my phone and then I'm ordering. That phone is not free. There's a certain cost involved in order to get that phone in my house, and I pay a certain bill, right? or I may order on an app, whatever, just 3 different ways. Whatever be the way, there is a certain cost involved with it. It's not free, right? And that cost which is involved in placing the order is called the ordering cost. Now, another very interesting thing about the ordering cost is it does not really depend on the quantity. So now whether I order 1 pizza or whether I order 50 pizza, my phone bill is not affected. My app is not affected. It's not that my phone bill says that if you order 1 pizza, then the cost is this, or this call is this. If you order 50 pizzas, then the cost is this. No. So it does not depend on the quantity of the order. It depends on the order. So if I'm making 3 orders, I am getting 3 setup costs, right? You understand? So it does not depend on quantity. On the other hand, the holding cost. Now, when that food that I have ordered or the vegetables that I have ordered, when they come back home, when they're delivered to my home, and I have to store them in inventory. So maybe I'm putting them in the fridge. That fridge is a warehouse. Yes, I have invested in it. It's not free. It is using electricity. It has a space. It's occupying space, right? Where I could have kept something else. So again, a cost. Now, this is the holding cost, right? Now, if my fridge has a certain capacity and if it is now filled, let's assume it has a capacity to hold 10 pizzas, 15 pizzas, 20 pizzas, or whatever vegetables, it's filled. Then I have to buy a second fridge, right? So the holding cost is somewhere dependent on the quantity. Now look at the beautiful relationship. There hits a point where this curve is minimum. And this is the point which we say is the economic order quantity. If you order this quantity, then we can ensure that we do not incur unnecessary expenditure to keep our inventory. Well, if this is by a graph, now we will solve that equation, because always remember, any equation, maths is such a beautiful thing, any equation, what is it? It's just a graph. You can always translate it into a graph. And that's what we've done. In this case, I've first shown you a graph, and now we will work on the equation. So let me come back to the class and we will try to solve the equation. So be with me and give me a minute. Okay, just a simple yes and no. Is my screen visible?
Yes, ma'am, it's visible.
Thank you so much. Okay, so we spoke about inventory and I said that economic order quantity. What is economic order quantity? So let's just first of all write the total cost. Do I need to increase the size? Can you read?
Yes, ma'am.
Okay, yes, thank you so much. So when we're talking about total cost, what are we talking about? We are talking about the cost of the product, and we are talking about the setup cost, and we are talking about the carrying cost. Okay, so let's put some abbreviations for different things. So P for me is price per unit. Let D be the demand, the annual demand, right? So how many units do I need in the whole year? Let K be the setup cost or the ordering cost, and let H be the carrying cost. I left out anything, of course, quantity, and let Q the most important thing, quantity, right? Now, what is my total cost? So my total cost, if I put this, is PD. Why PD? Because price per unit into annual demand. I'm just putting figures in the first line, plus K D divided by Q. Why? What is K? K is the setup cost. Now, what did we discuss? The setup cost is not dependent on the quantity, but it is dependent on the number of orders. And what is number of orders? Total demand divided by quantity per order, right? So this is quantity, means this is a quantity that I'm placing per order, okay? And finally, what is the carrying cost? The carrying cost is dependent on the quantity. So this will be H into Q divided by 2. Now go back to your 6th, 7th or 8th class, and if you remember, we used to do differentiation. What was differentiation? Differentiation is the change of rate. Remember speed? What is speed? Change of distance with time, and you do it with, and you write it with that differentiation, d upon dx. Now here again, we want to find out that quantity where the change in total cost is minimum or zero, right? You saw the graph. There was a point where the cost is minimum. So in order to find that, what will we do? We will differentiate. We will differentiate this with respect to quantity. And since I'm sure all of you must be preparing for competitive exams, or even go back to your 8th or 9th class, if you remember the equation, if you xn, I mean, do I need to write this? I don't know. Those of you who, forgive me, I'm not really great in typing. I will do this for you. So let me just put this into see, I told you I'm not putting this. Okay, I hope this makes sense. You remember your 8th class or 9th class? You used to do this. And now we use this equation only to differentiate this with respect to Q, because we want our cost to be minimal. And the moment you do this, when you differentiate, you will, do it with me. That will help you. Again, this Q is raised to the power 2. Okay, this Q will be raised to the power 2. Yeah, this is the equation which comes. Please solve it. The moment you solve it, it will become yes. And obviously, since we only want Q, we want the economic order quantity. This will be, sorry. Yes? If you're confused, don't worry. Just look at this. What did we do? We first understood what is the total cost. We understood the total cost is cost of the product plus the setting up cost plus the carrying cost. We need to put figures into this, and that's what we did. So there's a price per unit, and because the annual demand is D, so P into D is the cost of the goods. Now setup cost, we said the setup cost is per order. So How many orders are there? Very simple, D divided by Q. So we had K into D divided by Q. Then we had carrying cost. What is carrying cost? Carrying cost is dependent on quantity. So we took H into Q divided by 2. Now we want to find out that minimum point where the price is minimum, the total cost is minimum, because that's the objective of my logistics management. And if I have to do that, I go back to the fundamentals of mathematics and I understand that I can use differentiation to do that. So very simple equation, which we had learned way back, x raised to the power n, differentiated, it becomes nx raised to the power n minus 1. I apply it. If at any point of time you haven't understood this, if you do this, we are differentiating it with respect to q. So we get minus kd divided by q squared plus h divided by 2. Put it here, there, and so on. Q is equal to under root 2 kd by h. And this is my economic quantity. Such an important concept, because this helps me to order the quantity which will not increase the cost and at the same time which will not allow customers to go back empty-handed. Very interesting thing about this economic order quantity is, I don't know if you've noticed or not, the price doesn't figure anywhere. And the price has nothing to do with the economic order quantity, which is one of the most important things which comes out of it. If you're confused, then I will end the class at this point of time. I will stop the recording and I will come back to you and open the house for discussion to solve if there are any concerns or queries. So let me stop the recording.